So difference of squares. So if we consider the binomial x squared minus 25. So to factor, we'd have to look for factors of negative 25. And because I don't have anything in the center, you can also think of this looking like a 0x in the center. We would need those factors to sum to 0, which pretty much leaves negative 5 and 5 are my two options. So if I was to factor this, this would be x minus 5 and x plus 5. So like I said, notice that this was a square and this was a square. This is 5 squared, x squared. That's why we say a difference of squares, because we're subtracting two squared numbers. But when we did that, we get this. So both x squared and 25 are squares, so it's called a difference of squares. Note the result is two binomials of the form a minus b and a plus b. We call these two binomials conjugates. So when you have this, that is the conjugate, and it goes back both ways. Of x plus 5. So all the conjugates is two numbers that it's the difference and then their sum. Those are the conjugates. And it works, like I said, in reverse as well. So I just want to bring up conjugates because they will come back. So how to recognize a trinomial square? Or I think I was meant to say a difference of trinomials. How to recognize. There was a typo left on the slide of this. The two expressions a squared and b squared must be squares. There's no middle term, meaning there's no something to the x. And one square is subtracted from the other square. So if I have a squared minus b squared, that will factor into a plus b, a minus b. So for example, if I have x squared minus 49, well, that is just x squared minus 7 squared. So because it's a difference of squares like that, I know that how I just factor this is I'd have x minus 7 or x plus 7 and x minus 7. All because it's that difference of squares. Oops, that was my solution there. So, yeah, okay. Sure, remember which ones it was. So 16, 17, and 18. So one of these, you actually would have to factor something out first, so you'd have squares. See if you can factor these with the difference of squares. So for 16, we got 16x squared minus 49. So 16 is just 4 squared. So because of rules of exponents, I have the same power. I can pull out that power and just say, well, that's just 4x squared. 49 is just 7 squared, which is going to stay here. So I have a difference of squares. So if I was to factor this, it would be 4x minus 7, 4x plus 7. Or you could have written it the other way. It doesn't matter which one's the plus and which one's the minus. It's going to be the same. So in the case of 17, we got 44a squared minus 18b squared. Well, 44 is just 12 squared. 81 is just 9 squared. we pull out the squares, I'm going to have 12a squared minus 9b squared. So now I have a difference of squares. So I'd have my two conjugates. I'd have 12a plus 9b, and I would have 12a minus 9b. So 18, we have 3m squared plus 4, n to the 4 minus 27n squared. All right, so we want to find these squares. So what we can do is we notice that both of these are divisible by 3 and an n squared. So I can pull out a 3n squared, which will leave me behind a m squared and an n squared here. So we still have that one, minus 9n squared. So this is the part we're going to worry about trying to able to factor. So I'm going to just keep this out here. But we know this is just mn squared minus, well, that's just 3, so 3n squared, because that's just 3 squared. So we have 3n squared here. Now we have a difference of squares. So we have mn, and then the other square is the 3n. So this factors into mn plus 3n times mn minus 3n. Oh, you know what? There's a little mistake here because I pulled out that out there. That's right, that n there is no longer there. Sorry about that. I just realized that I left it behind. There we go. So 9 is 3 squared. There we go. So we have a difference of mn plus 3, mn minus 3. All right, and this last little bit here, a sum of squares cannot be factored. We will demonstrate with the sum of the squares below. So we have x squared plus 9, which is 3 squared. So if we were to try to factor this, this is the same as saying that I have x squared plus 0x plus 9. I would need two numbers. They're factors of 9. And then I want the sum of those factors to be 0. Well, my choices are 1 and 9 and 3 and 3. To make that be a 0 would mean I'd have to have a 3 and a negative 3, which I can't have because this is already positive. So neither of the factors of 9 are going to sum to 0. So when you have, like I said, a sum of squares, that is something that we cannot be factored. So that is a prime.